Alright, hello everyone. So let's solve another differential equation using separation of variables method. So we want to make the right hand side separable. We want it to be a function of x times a function of only y. So what can we do here? Well, let's see. We can factor x out, right? So if we factor x out, it's going to be x ex times y minus 1. So it's clearly separable. So this is a function of only y and this is a function of only x. They are multiplied together, so it's easy to separate them, right? Perfect. So let's separate. We can take y minus 1 to the left, so it's going to be dy over y minus 1 and x ex dx. Okay, so this problem is going to be slightly different from the example that we saw before. Now let's integrate. Now if you integrate the left hand side, it's going to be very straightforward. If you know the basic integral rules, it's going to be natural log absolute value y minus 1. Okay, now how do we integrate right hand side? So let's pause here. This involves a lot of integration, right? Clearly separation of variables involves a lot of integration. So you have to review basic integration, integration by substitution, integration by parts. So if you want to review them, the links will appear right now in the video. So click them, go to them and review your integration skills. All right. Now the thing here is that to integrate the function that we have in the right hand side, we have to use integration by parts. Okay. Alright, so why we have to use integration by parts? That's a topic for integration. But you can go to integration by parts video series playlist and learn integration by parts from scratch, or if you are comfortable with integration by parts, you can quickly review it. Alright, okay, so let me do this. Let me do it separately here. Now we want to integrate x e to the x with respect to x. So we have to use the formula. So the formula is u dv is equal to uv minus v du, the integration by parts formula. So we have to choose u and v, dv. Now u is going to be x, dv is going to be everything else, e to the x dx. Now why did I choose in such a way? Why didn't I choose u to be e to the x? Well, that's a topic for integration by parts. Okay, so again, if you want to know why, go to integration by parts review video series. Okay, all right, perfect. Now we know u and dv. Now we definitely need to find v. So to get v out of dv, you have to integrate what we have here with respect to x. So if you integrate e to the x with respect to x, you get e to the x. So that's our v. Pretty simple. Now we need du. So to get du out of u, you have to differentiate x. So if you differentiate, so du over dx is 1. If you differentiate x, it's 1. So du is 1 times dx. So it's dx. So we have all the tools we need to use integration by parts. Perfect. So u is x, v is e to the x, minus v is e to the x, du is dx. Alright. So to finish off the integration, we just need to integrate this. So e to the x, integral of e to the x is e to the x plus constant of integration, let's call it c1. Now this is the solution. This is what you get if you integrate x e to the x. Okay, all right. So if you are completely confused, that means you have a problem with integration by parts. Again, as I said, please review it. Okay, I did that fast because I expected you to know integration by parts by now. All right, let's see. So we found the solution, haven't we? Let me erase this and make some space. This is natural log absolute value y minus 1 equal to what did we get from the right hand side. So this is what we get, x e to the x minus e to the x plus c1. Perfect. Now let's say you want to find the explicit solution. So to find the explicit solution, we have to take the e of the right hand side. So it's going to be y minus 1 is equal to e to the x ex minus e to the x plus c1. Now what we can do here is we can break up this c plus c1. So it's going to be y minus 1 e to the x ex minus x e to the c1. c1 is an arbitrary constant. Okay, you should have written that there. But let's see, c1 is an arbitrary constant. So e to the c1, you can choose it to be what, let's say c, because it's also arbitrary then. So c e to the x ex minus x is equal to y minus 1. Okay, so this is a little bit messy. So let's take minus 1 to the right hand side to get the explicit solution. Y is equal to c times x e to the x minus x plus 1. Okay, perfect. So this is the explicit solution for the differential equation. All right, thank you very much. So if you are not comfortable with integration, please review it as soon as possible. Okay. Alright, hello everyone. So here's another differential equation for us to solve using separation of variables. Now here's something you can do. Pause the video, write down this question in your paper and try to solve it, and then try to compare it with my solution. Okay, so that's a good way to learn mathematics. Now here, this differential equation is simple enough because it's sort of like the right hand side is separated, because y square is the function of only y and the rest is only function of x. So the separation is super easy. We can take y square to the left by dividing it, and x minus 3 over x cube can stay on the right and take dx to the right. There we go. We have completely separated the differential equation. Perfect. Now it's left us to integrate. All right, now why is this problem important even though? Now we want to integrate. Let's be careful. Here's a one common mistake. So the integral of left hand side, some of you will write it as natural log y square. That's not true, that's wrong. Okay, you can write it as natural log y if it was y, if it was a linear term, like if it was y to the power 1 term, but here it's not, it's y square. Okay, so that's something that comes with basic integration. Again, if you're confused, go to basic integration review video series and review it. Perfect. Now how do you integrate this left hand side? Well, let's just rewrite it. We can rewrite it as y to the minus 2. If you can take y square to the numerator, and all of a sudden the power becomes negative. How about the right hand side? Now that's look a little bit complicated. How do we integrate that? Well, we have to use an algebraic trick. What we can do here is we can divide each term in the numerator by x cube. So see what I'm going to do. So it's going to be, if you divide x by x cube, it's going to be 1 over x square. If you divide minus 3 by x cube, it's minus 3 over x cube. So I just rewrote both sides of the integral. Okay, so that's crucial. Now we can integrate y to the negative 2. So it's y to the negative 2 plus 1 over negative 2 plus 1. So if you integrate, now to integrate 1 over x square, you have to write it as x to the negative 2. For the same reason why we wrote 1 over y square as y to the negative 2. To integrate, okay, here also we have to write it as x to the negative 3. Okay, alright, that helps us with the integration. Now y to the negative 2 plus 1 is negative 1, and divided by negative 1. This is going to be x to the negative 1 over negative 1. Similar integration with left hand side. So here minus 3 x to the minus 3 plus 1 over minus 3 plus 1. Here just I was lazy. It should have been minus 2 plus 1. But I was lazy to show that step. Oops. Don't forget the constant of integration. So this is going to be minus 1 over y, because you can take y to the negative 1 to the denominator. Here it's going to be minus 1 over x. We can write x to the negative 1 in the denominator. So it's the power become positive. So here it's minus 3x to the minus 2 over minus 2 plus c1, sort of simplification. So minus 1 over y minus 1 over x. Here plus, okay, with this negative and this negative, 3 over 2. Let's take x to the negative 2 to the denominator. So it becomes x square. Okay, it becomes positive power. All right. Now this is the implicit solution. So how about if you want to find the explicit solution? So here's what we can do. We can take this negative to the right hand side. So it's 1 over y. If you multiply everything by negative, it's 1 over x minus 3 over 2x square. Here you can write it as plus c1, because it doesn't matter. Even though you write it minus c1, it's also correct, but I mean c1 is an arbitrary constant, so minus c1 is an also arbitrary constant. So you can write it as c2. C2 is basically minus c1. Doesn't matter. Okay. All right. Let's see. Now we wanna find y explicitly. So what can we do? We can flip. So it's going to be y. We can flip both sides. So that does not mean the solution on the right hand side is x over 1, 2x square over 3 plus c3. Nope. Flip, if you're gonna flip, you're gonna have to flip the whole thing. Okay, so it's going to look a little bit ugly. So this is going to be your flip. All right, this is going to be the solution. Okay, think about it a little bit. Okay, you cannot flip term by term. Okay, that violates the algebraical rules. Yeah, so that's it. That's the solution, explicit solution. Yeah, thank you very much.